y'all for joining. We're going to start here in a second. We're just letting all the YouTube notifications go out. I will fix the music next time. And I just want to fix one scene and we'll be off to the races. There we go. Oh, I did not have studio mode on. Well, what is up, y'all? I'll just come here. Thank you for joining. We're just going to take an hour out of the afternoon just to hang out, and we're going to do some code practices. I did figure out what was the issue for getting some of the easier Code Ward challenges instead of the harder ones, and we're going to kind of start off with those, and just to get brush up on our fundamentals and to write nice functions, make them more efficient. As always, I have the Discord room open, and there is a live Discord link in the description, and the Code Wars link is not there. I will fix that right now. This is the stuff you do on the fly. Join me in Code Wars. And what's the wording? Follow me at bam. Save. There we go. The description's right. Jeff, we have in Discord. How you doing?
I'm doing good.
All right. So I got studio mode up and going now. So let's go ahead and find the right scenes. There we go. Boom. And I have my profile up right now. It's Code Wars Marvin 117. I am a skill level 6. And as the number goes down, the better you are. I just have my solutions page pulled up because I figured out what I was kind of doing wrong in getting the level up challenges. And those are the challenges that you do to kind of level up. And they are much more intent, or not intensive, but a lot more than just doing some simple fundamentals. And that's what I was initially expecting. Some iced
Can you
tea.
share the screen to Discord?
Yes, I can definitely do that too. Let me get that set up. Full projector window. Put it over there. Making it big. Yeah, let's redo that. To projected window. There we go. Ha ha ha. Look at that. I am doing a thing. So we're going to go ahead and kind of get started here. There was one that I found that was interesting. Find the smallest integer in the array. That was easy. Sum the two lowest positive numbers. That one was kind of fun. And I think the solution for that was all over the map. Let me pull that up and go to solutions. Now my solution, let me show here. I took the function itself, and it's a number of integers in a vector. The steps did say that your vector will always be 4 or more, but you never trust people calling your function. So I went ahead and just checked that too. And my vector minimum size was 2 because I took the first 2 elements in the vector and I assigned them to my lowest array. And in this array, I check the array and see if the 1 is larger than 2, and then I swapped them around. If they weren't, then the numbers were already sorted with the 2. I did not want to use a sorting algorithm on this because the O of n on sorting algorithms is n log n. So that means you go through the array at least once, and then you do it log n more times. And that that is fairly efficient for sorting. However, I can do it just go through with just n times. So my algorithm is faster than running a sort algorithm, which a lot of people said here is clever and best practice. Yeah, leading on the standard template libraries, I would say it's better practice, but and kind of clever for using those containers in that manner. However, it's not the fastest and most efficient. So that's why I didn't use a sorting algorithm. I thought about trying to write one like quick sort, but there's no need because time you go through it once, you can already find your answer. So I started then with the index of 2, check to see if the current index is lesser than our least indexed, because I was initially comparing it and just swapping out of the numbers. But if you don't do a shift, if you find a lower number to move your lowest number that you thought it was the lowest, and you find a lower number, if you don't shift that number that you're replacing over, then you get a wrong answer. And it was happening. And then when I realized that, I was like, oh, I need to do a shift. And I do the shift. And else, if the current number is less than our highest, less than lowest number, then I just replace that in the to array, and then at the end you add array 0 to array 1. There were similar solutions. I think right after that guy was a similar solution. He has low 1 and low 2. He did set to max value. That's pretty cool. And then just ran his algorithm on its own right. If I is less than low 1 equals low 2, and then I, because he's using a for loop, and for each loop, and then he's just assigning I to it, and else if I is less than low 2, and then just returns the sums. Pretty much the same thing. He's not using brackets, and this is where I will not put for best practice, because putting curly brackets around your if statement is always a thing that you need to do, because if you just kind of don't do that and you need to add a line under here sometimes, you'll forget to add the brackets, and then your code's not executing how you think it should be executing. So best practices like this gentleman is always add the brackets to your code, and he did here using std min and max, which is pretty cool. Pretty cool on its own right, but it's still doing the same thing that my algorithm was doing to see which one was the lowest. Um, but he's doing that in such a way he's finding the min and finding the max. I'd rather do the comparison operation once, and then we know the answer, and then do the assignments after that. But I'm not going to knock him too much on it, because he did all the brackets correctly, and also the brackets on the new line, which in this application I'm not knocking people on.
I would also knock the previous entry for bad tabbing.
This up here, yeah, because it's all over the place. He might have wrote it in something else, but and then copied and paste, and then the tabbing went wonky, because if you write it in Notepad, sometimes, yeah, it looks like he's using tabs here and then spaces here, and that's how it got all wonky. Some of them are tabs and some of them are spaces. Nth element, I had to look this one up yesterday, and it's kind of a weird sorting algorithm that you can run on yours with a comparison statement, and it's kind of like a bubble sort, that what he's doing here, but that is also gross. And then there's a bunch of other sorting algorithms people are pulling out. Copy if, that was interesting. I learned about that. Another sort. And then their solutions are pretty much starting to become repetitive. That was a fun one. I am surprised a lot of people are just going to a sort by default, because it is not the fastest way of doing it. So let's go ahead and just go home now. And we are just going to look at this one. It's just the first one here. And forgive me reading, but reading out loud is difficult for ADD people and dyslexic. So here we go. Write a function that takes an array of numbers and returns the sum of the numbers. The numbers can be negative or non-negative integers. If the array doesn't contain any numbers, then the array should return 0. Well, that sounds easy. Oh, but there's also a decimal. But he was saying integers up here. Negative and non-integers. Okay. So we're just going to keep the types right, and that should be easy. Assumptions. You can assume that you're only giving numbered, well, based on your types, that should be easy. Cannot assume the size of array. Well, if you pass a good array in, then we can be dynamic on that. You can assume that you can get an array if you array a number. What we're testing when basic tests of the loops and mathematical algorithms, this should begin where you're just learning the loops and operations, blah, 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 blah. All right, let's click train. Let's see what this thing looks like. He gives a int of vectors, but his input here has a 0.2. And you can't have 0.2 with an integer. So, okay, I'm just throwing that out. Because, yeah, I'm just going to keep it the same. And we're just going to do int sum equals 0. And then we're just going to do a for each index value, because I just like using the word value of nums sum plus equals value. Well, this one's just going to be pretty easy. I wonder if I can get all this in one run. And for the hell of it, I am going to put that on this new line. Boom, boom, boom. Space for thought. Do the thing, do the thing. Hit test. Are we going to get green the first time? Yes, we are. Are we going to get green on the attempt?
I don't see anything wrong with it.
Yes, we are. One and done. You got all the random. I wish it would show us the values that it's given for random. Because down here we see what values is going to be given here. The first thing it's going to give you is an empty array or vector. And then this for loop handles empty vectors already, because if it's empty, it won't go in there, and I just return 0. So I don't even have to check for 0.
Yeah, that's a good handling of it.
So let's just see what people did. Accumulate. Okay. And it returns a value. I don't know this guy, so let's go ahead and look at it. std accumulate. And we go to the best reference, C++ reference. Returns the results of accumulating all the values in the range first to last. All right. And its signature is an iterator to the first, iterator to the last, a T for the type of it is, I assume, int. The same thing again, and let's look at the parameters. Initial value of the accumulator. Okay. So you can precede it with a number. That's kind of cool. And iterators are iterators. So if we look at this, he does vector begins to vector ends, and that will give you an iterator. Oh wait, that's a sort. Where did this guy? Oh wait. There we go. So he's passed in nums, and we got a begin to end for the vector, and his initial seed value for the sum is 0. Okay. That's probably the same thing that everyone else is doing. Count for int I. Okay, I give this guy props for specializing the type.
I like the auto better just because, like you pointed out, the original description used a float or a double.
Mm-hmm.
So if you were to change it later, it's one less place you have to change the type versus having to change the type of the for loop as well.
Yes, you are right on that. And I'm just going back and check the chat. Oh, Don, I didn't see your chat because you were covered by a window. Thanks for joining. Um, what in the array indicates a position without a number? What in the array indicates a position without a number? Well, since it's an integer, all of them have to. I don't know when you posted that. If a position in the array doesn't have a number, it's not like I forgot C sharp. C sharp has a value that can be unset or set, and since it's an integer, in this use case, then it's always guaranteed to be a number. Um, I sorry I didn't see your post until now.
I think technically you could probably have a null value in one of them. That would still
Null will be zero.
follow. Okay, okay. I didn't know if the C++ had it treated it different, a null versus zero.
No,
Into
C
for
sharp kind of
integers.
has that, but
Okay,
for strings and a couple other things. But C++ doesn't. It takes that memory reference that's set to a side, and then it's just that raw data there. If that's why you got to guard yourselves when you're setting and creating values. So you set a default initialization value, so that initial set is something. If all right, so he says if that's the case, then the task makes no sense. Yep. Okay. Well, we got an easy one. Some of these are fun. Return a number that counts the vowels in a given string. Consider A I O U as vowels for this, but not Y. Aw, but why not Y? The input will be a string only consist of lowercase letters and or spaces. I see a simple for each loop on this with a switch. Yeah, because switches are faster than doing if else trees.
um, would it be? I'm for some reason I'm thinking a constant vector slash hash. Um, would that be faster?
I'm thinking about it. Like, do a hash, put it in a map?
Um, yeah, that would yes. That's yes. Put it in a map, and then if the character is in the map, then it's a vowel, and if it's not in the map, then or if it is in the map, then you uh, increment the counter. Otherwise, you go to the next character.
You got to be careful with maps sometimes. If you do a find, then it's doing a search. If you try to reference the index position, let's just kind of type it out and I'll walk through what I'm thinking about. So if we do, and this guy is using std, I just nuke that. We want an unordered map because unordered maps are hashed. Unordered underscore map. Hopefully I spelled that correctly. And we want to create a map. Let's put it in scope. Unordered map. And we want to do a car to an int for the count for it, right?
No, there would just be car because the count is going to be is the line above it.
The count is the line above it. You want to.
Is your number of vowels.
So what are you gonna put in the map? Are you gonna map out all your vowels?
Yeah, that's what I would do.
A,
Just have a
E,
map.
I, O, and U.
Yep. And then if it matches, if it's in the map, then it's a vowel, and you increment the count.
Then you're not really using the maps because maps are the key. So our key is going to be the vowels, and our ints could be just the count of all that how many letters it found for A, E, I, O, U um, by themselves. If you're trying to go down your hash way, what's a hash? Is there a hash list? In computer science, a hash list is a type of blah 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 blah. Let's just slam C++ in the front of it. Hash tables.
It's technically it's pointing to something else. We're just in this case we're not needing that.
Yeah,
At least that's my understanding.
if you're gonna do that, say we create this and we call it map. Then you have to do a dot find to see if that value's there, and then you got to check if because it's going to return iterator, if this iterator is equal to map.end. It's just a lot of extra steps. That's one way of doing it. You can also use map.at. I think that's right.
At returns the iterator as well.
Yeah, but at will also. I yeah, I know, Don. I'm just walking down this path. At will also do a search of the tree. No, well, it'll quickly do a hash of that value that you give it and see if that thing's there. However, if you just do this value plus 1, it will create that in the map. So it's not really checking it. So you have to do the find or at functions. And then you're searching the tree and you're going to do n log probably n for your running operation. So it will actually slow you down in the end.
Okay. I didn't know. Depending on how the data types are set up, I didn't know if it would be faster.
Yep. It's a good idea, and that's why I just wanted to run it through and explain why I wouldn't go that path. But maybe you found something that I wasn't seeing, and so I just wanted to run through the path. There is no bad questions. That's what I tell the interns. Let's just run through the idea, see if it works, see if it doesn't, and learn from and see if we can find any lessons there. Now, the reason why I like a switch is, and I wonder if Don's going to say anything. There is the fall through statements. Depending where you work at, they are good or bad. A, E, I, O, U. And they said it's all going to be lowercase, but I am not going to trust them. And we're going to do the uppercase. A, E, I, O, U. then since all these case statements are stacked on top of each other, if it's any one of these, it's going to keep following through until it runs to the statement and finds its first break. But we are just going to do number of vowels plus plus, since we know we're starting at 0 already. And then we're just going to break it here. And retype that because cap locks was still on. You could add a default if you wanted to. Sometimes you get compilers that will say, hey, your case statement doesn't have a default. What if it's unhandled? Well, then if I didn't write a default case statement, then I don't want anything to happen. We might put continue to force it on the next loop. And just let it fall and get out of the statements. C# will also force you to have a break to your default. And since I took std using out, it's complaining. Oops. std. Ooh, I do not like that. And it should work. And it's not liking that. All right. It should still be character string. Attempt. Now this will give us the fastest runtime to run through each of the letters, and you could do if else, if else, if else, if else, if else, if else, but if you do the if else tree every time it goes through, it has to iterate through that tree until it finds one or none. A switch statement, it will give you a direct go to jump under the covers and jump you to the right case, and you don't have to check all the other cases. I like fall throughs. I forgot there's a language that you have to specify fall through. Maybe C# to tell it that you're meaningful to fall through. I ran across it once or twice. Also, if you want a quick note, this was the Internet Explorer issue a while back. There was fall throughs in their case statements because they didn't write break on one, and then every certificate that you accepted, good or not, was accepted as valid. Yay. This guy wrote a is val. I'm not going to knock him too much on breaking that out because that makes it more unit testable. And then you can just unit test this guy and see if this function runs correctly. However, these ORs together, you just created the nested if-else tree. I would rather switch. Case statement. Get count. He made a anonymous function here. The beginning to end. I think this is another STD thing. And it is. Iterates through 2 iterators. And it takes a function pointer. And you define what that statement is. And he does a switch here, return true, default false. Yeah, I wouldn't call that clever. I call that showing off. I hate anonymous functions or lambdas. They're actually called lambdas. Dislike them. Dislike them wholeheartedly. Here's a nested if statement. Even if you nest them like this and it's still written 1, You will have fall through shortcut logic. There's the word, and it will still check if O false, if E false, if I false, if O false, if U yay, and go into your statement. So you're still paying the if else tree piper. It works. It makes it all one line. Nah, I don't like it. Same if else tree.
If you're going to do that, then I would order it by actual relevance versus alphabetical order.
Here's another if else tree. He has a C out, so he was debugging. You left it in there. Another count if. Vowels find to lowercase. Oh, okay. I do like this guy. He forces the lowercase, but he's also doing a find. Yeah, you're gonna probably have a longer runtime than what I wrote.
Yeah, if you're gonna do that, I'd like to do the hash table.
That example is more clear. All right. I'm kind of done looking at this guy, and kind of the same thing, but he's doing it each case break, not using fall throughs, which is fine. All right, well, I'm done with this guy. We go home. Let's see if we can find a decent. Here's a 6. You are going to be given an array of integers. Your job is to take that array and find the index n where the sum of the integers to the left of n equal the sum of the integers to the right of n. Well, that's interesting. That's almost like a quick sort kind of way of breaking it up, but you're not sorting, you're summing. If there's no index found, and you're not sorting these. For example, let's say the array given is 1, 2, 3, 4, 3, 2, 1. Then that index position 3 is the sum of these plus those. So in order to find this, it doesn't have to be equal. Does it have to be equal? So if it has to be an odd number and you step through it to the middle position, that's kind of easy. You start one here and start one here. You just keep adding until you get to the middle. Okay. Because the third position is the array, the left side, the right side. All right. Look at this here. To answer Don's question, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 3, 2, 1 is a palindrome. We did palindromes last time. So it's just not that quite simple. Index is 0 left. Please remember that in most languages, the index of the array starts at 0. We can run through this. How do we want to run through this? We can iterate through each position, but then we have to do a sub loop to iterate through what number. Let's call it pivot position, because Quicksort uses pivot positions. So we start with an index pivot position. We add up all the numbers to its left as we iterate through the pivot position. However, every time we pivot, we got to decrement that number or keep adding. Oh, what if we have the first iteration? Can it? Can it? So we always have to start a pivot of 1 and then add up all the numbers. And then anytime we pivot to the next one, we subtract that from here and add it to that side. Ah, and then it just be n plus n minus 1 for runtime. Okay, that could work. Note you're given an array with multiple answers. Return the lowest correct index. All right, so just find the first one. How can they have multiple? That's weird too. Output the lowest index where the side of the left n is equal to the side of the right n. If the length of the index is 0 to 1000. Please remember in those languages the index starts with 0. Index 0 of the left side is 0. So if this is our pivot and there's no other 1, it just says 0. Can these numbers add up to 0? Yep. I transitioned. I didn't go back. Thank you. My 2 numbers are palindromes. That's funny. All right, screw it. This sounds like fun. Blah, 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 blah. Expected 0. Okay. 0. Expected 0. We're just going to do what? And this guy's also using std string. Screw it. I'll just accept it. They're all integers. So let's just stay integers. Left equals 0. And right equals 0. Right doesn't. I don't need to set the default of right, but we'll just do it out of habit for it index. Yeah, index equals 0. 0. Come on, Frank. Type 0 less than 0. 0 less than numbers dot size and index plus plus. Integer, and we're gonna call it index. So we're keeping index out of the for loop. Oh, it's going to probably complain there's no return. So we can return it. Oh, screw it. No, I'm going to put it inside and just do the return inside. It doesn't matter. We can do that after we find the happy if left sum. I'm going to make a more is equal to right sum. What's up, man? How you doing? Glad to hear it. Just a heads up, we're live on the 2Beat Frank channel. Cool, cool. Just giving you a warning. I trust you. All right. We need a first run through to sum up all the numbers.
You could use that standard accumulator.
Yeah, that's what I was thinking. Accumulate. We're just going to check that. Spell it correctly. Boom. All right. So we're going to accumulate numbers dot begin plus 1, because we don't need the first n number to be in it. Then go to numbers dot end, and it takes 0 to start it out. It doesn't like this. All right, we'll check it. Accumulate C++. And accumulator.
Nope, never mind.
Accumulate. An iterator to an iterator. I always like the first someone shows you. Accumulate numbers, number plus 3. What is number? Yeah, maybe it doesn't want begin and end. It wants, yeah, here we go. Iterator to the first, iterator to the last, and T a number.
An initial value.
Yeah. And it returns what? Returns the number. It returns through first dot last. Return int. Okay. You can give it functions. I think that's right. All right, I didn't do the sum. We'll fix sum right now. Sum, and equals. Oh, I did not. Yeah, I have insert on. I'm so used to IntelliSense.
Maybe I didn't read this in the instructions, but if the whole string evaluates to 0, so all the arrays evaluate to 0, would the index of the left side versus right side be 0? Because if you have nothing on the left side and everything on the right side adds up to 0, then
yeah, it says index and index 0, the left side is nothing. Given array, blah, 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 blah. And index 0, the left side is empty. The right side has 10, da 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 da. Both sides equal to 0.
Okay, so then the accumulator, you don't want to start at +1, you want to start at the beginning to check that.
Well, it says the right side of this. So the pivot index is 20, 0. The left side of 0 is an empty array.
Oh, okay, never mind. Okay.
Then the
I didn't realize that I misread, or I did not catch that there was a pivot that was ignored, or that was not added. Never mind.
Yeah. So
Sorry about that.
yeah, it's a little confusing. No, it's not working. Hold on. Error use of undefined accumulate. What space are you in? Ah.
Standard, and you're using standard.
It's in numeric. Got
You forgot the okay. You forgot the header in time.
yeah,
Okay.
yeah. Okay, and we're past that. Undeclared first use of index. Index, index, return index. What? All right, so you are giving me a warning because, yep, T size to size, that's fine. I don't want to change that.
Do you have return index at the very end still?
Yes. Good catch. Good catch. All right, so it's running, it's failing. That's fine because it's not really doing much. Um, if it equals to each other, else. Here we go. Here's the fun one. Left sum plus equals numbers index, then right sum minus equals numbers index, and then we iterate through and see if the sums are equal.
Should that be you're subtracting off the index plus 1?
Yeah, I was about to think through that. So if we start at index 0, 20, then it will add up this side to that side.
Because
Then
you
index 1, then we need to take 20 and move it here. Then subtract index plus 1. I see what you mean. From here, and if we do that, if we're looking ahead, we need to make sure we're not going to overflow it. Something tells me it's something weird. We got to guard against that, but how do we handle it? We slap it to 0.
the lemon and the for loop.
And we'll just set it to 0 because it should be empty by then, and if it's not, something else bad happened. And we came 6. We missed it. So we went expected 3, got 6. 1, 2, 0, 1, 2, 3, 4, 5, 6. It's hard to debug this and see what's going on. We're going to open up our fancy Visual Studio so we can just run through it.
Can you paste that link into the chat?
Yeah.
So I can pull it up on my computer. I can pull this challenge on my computer.
Yep, it's going to be in the Tankers audio chat. And I will also throw this big one into here. I don't know if we're going to finish this in time. I wanted this to be a quick hour so I can have lunch. Why do I have to tell it to find Discord or where is the window? That's console. We don't have console yet. Discord audio. Ring pan Visual Studio. I have to point to Visual Studio again. There we go. All right. Simple. Nope, that's not what I wanted. And then we'll call it with this array. Here we go. All right, we're debugging. We jump into sum of 0. Right sum is 15. That sounds right. They're not equal to each other, so we take our index is 0, numbers 0 is 1. Hold on. We don't have 1. That's probably it. We don't have 1 to that side because 1's our pivot. It's not in there.
No, that's you're adding it to the left. You're adding the pivot to the left, and then you're taking off the new pivot, which is index plus. And oh, you never
I messed this up. I didn't do the sum here. Okay. We got the pivot index. Then we need to add the pivot index to the left sum. And then we need to subtract the next pivot index from the right sum.
correct. Yeah.
So it needs to be, I think you were...
Yeah, you put the exclusion to make sure it doesn't go outside the array, but we never did add the actual moving it the value.
Let me move our chat window. Where did our chat window go? What's up, Kyle? We're just having fun. So we're taking 0, which is 1, and adding it to the sum to the left. We're going here. Then we're taking the next 1, which is 2, subtracting 2 out of the sum, which will be 13. Yes, blah, blah. All right, we're 3. 3 is supposed to be good. 6 to 6. Ha ha! He says to himself. All right. I think we're going to get caught in some of these edge cases. Kyle says, my pivot index in my living room couch. That is so true. Hey, pass all the simple test cases. Let's hit the other ones. We passed them all. We got random. We got the core. Do we want to do any cleanup? No. I still see my runtime of this would be n plus n minus 1. Yes. You're not really doing good guards on if size is 0. But it let us submit it. So I'm happy. And I'm going to label that as the big code war. That was a fun one. Not too difficult. I like a 6. There's in the description. All right, let's take a look at these. So this first gentleman, the one that has the most best practices, he's going from the index like I did, but he's doing it at the top. One thing we haven't talked about, let me switch back to the code screen, is creating values inside your for loop. That creates a bouncy stack because every time you iterate, it's destroying those values and recreating them, destroying and recreating, destroying and recreating. Every time you go through the loop because you're ending the scope of that function. So every time this runs, once it hits the end of the scope, it destroys left sum and right sum. And then next time it goes through it again, it re-enters the scope of the function, and then it recreates these values on the stack. So you're doing a lot of calls to the operating system. Hey, I need new memory. Oh, they're gone. Hey, I need new memory. It's gone. Hey, I need new memory. It's gone. So I would prefer those to be moved outside the for loop and then just reuse them over and over and over again. It's completely fine. And especially when you're just calling this function and you're right at the top of it, yes, do it nicely. You scope those values to the function and not the for loop. Ooh.
I don't like how they're adding the whole
Yeah.
adding them each time.
This would be like almost a bubble sort each and every time. So it's n multiplied n minus 1 multiplied n minus 1 is your runtime on this. So for each iteration, we're going through it n minus 1 iterations and again n minus 1 iterations. No, only once.
Only once because you're doing
Yeah.
hard on one side.
So my solution had a plus n plus n minus 1. This has a multiplication because for each iteration, you're iterating through it again. So you're going through it kind of like a bubble sort, and then you're doing this each time. So, gross. No, I will not give this clever points. I will not give this best practice. There's a lot of things wrong with it. Let's this guy. Some parts. I was about to say this looks like mine, just slammed together, but it's not. Sum parts on the right. He did the same accumulate. Checked right off the bat if it's index 0. And then he goes in here and he does his work at the top of the loop. I did my work kind of at the bottom of the loop. Check for was it the winning scenario? No. Okay, then we do work. He's doing work at the top, then checking for your winning scenario. And then moving numbers minus 1 adds it because our pivot's 1. Minus 1, so he's always guaranteeing. Okay. So this way he doesn't have to check to going over. Okay.
Yep.
I will give him clever, and I'll give him clever. Best practice? I can't see too many things wrong with it other than I hate how he has if statements on the same line. And that's fine. If statements on the same line, you need to do curly brackets. So no best practice. Okay, so we haven't talked about this much. I don't know about this line. I hate it, and I see the convenience of it. I hate declaring multiple values on the same statement. Int this, int this and that, this and that, this and that. I've done it in the past, but I've gotten the way out of it because it's harder to read. Because when I initially read this line, I see sum r equals 0, and my eyes jump to the next line. It blows away everything else out of it because I see that as a function call. So when I'm reading function calls, like this here on line 35 in Visual Studio. How I'm reading this, I am looking at it and say, okay, there's an integer in my mind. The integer is find. It found something, and I don't really care about the function call. If I need to go into the function call and debug it more, then I will, right click on it, go to definition, and then I keep reading again. Anytime it goes off and does this thing, I don't care. I see integers and I see patterns, how the words are, and that's how I read it. And if you do the declare multiple values on the same line, I throw everything off that second value away. Just because I see the default go-to to me is it's a function call, and I don't care what the function call is really doing. All I know is it's an integer, and if you named your values correctly, it found something at that point. For loop on the same line? No. You're asking for a disaster. Get rid of it. It needs to be separate lines, curly brackets. He has a curly bracket here, and iterating plus and minus okay. At the end, -1. Good default value. Always have a default return. Where's the success return? Hold on. Oh, I didn't see it because it was on the same line. No points. No best practice. Best code practice? No. Clever? No. You're gone. You're gone. You're getting grumpy anger. Old programmer guy angry here. Multiple values on the same line. He's declaring length. Yeah, okay. This is only a one line execution. It's only going to take one clock cycle to redirect and grab that value and return it. There's you can do it. You're sacrificing memory for a kind of a quicker running program. The majority of the time, we don't need that efficiency, but it's fine. And he has 2 for loops. Pretty much, he didn't use the standard container. He did it that way, and he did it this way again. Oh, this is going to be slower, though. He's multiplying.
And he's adding up each. He's doing the same thing the first guy did, and he's adding up all the numbers each time.
Yep, I will make him redo this. If we're looking at efficiency, and he wants to be super efficient, and that's why he's declaring length, you need to get rid of your multiplication. Your multiplication's too.
And get rid of going through the loop each time for adding up all the sums. That's also inefficient.
No, well, not each time. He's adding all the sums up here. Since you don't see any curly brackets around this if statement, he's only doing it there and then going here. And then sum of all the numbers minus his current position at return that value. I don't know why he's doing multiplication. Multiplication takes 4 clock cycles. If we're doing super efficient, and division takes 8 clock cycles. I know that because I had to tweak a algorithm to that extreme. Before
you're right. I misread because of the single line.
See? Wait. Do I have your audio encoding? No. I don't have. Is Discord audio coming through? It should be coming through. Uh-oh. Say something real fast, Jeff.
Testing 1, 2, 3. This is Jeff on Tank Radio.
No. I've been talking to myself the whole time. It says it's there. Oh no. Oh well. It is what it is. We're at the end of the stream anyways. I'm just gonna unmute my desktop audio. It was supposed to be coming through Discord audio, but it's not added to this scene. Beta, capture, Discord audio. So you were there sometimes and not other times. I'm sorry. We'll get better. Let's just look at this guy. He has it down to 4 lines. He's doing a sum of all the numbers, and we remove the pivot. His left is there. He does a find if index equals at the end, and the if is the statement if left plus number returns sum of left of multiplication. Do not like it. I will have to sit down and figure it out. Plus a ternary at the end. If the distance between I and... No. No. Not clever. Not best practice. He's kind of showing off. And I don't like show-offs. All right, ladies and gentlemen, thank you all for watching. This has been fun. This has been me coding. Sorry about some of the audio issues. I'm still trying to get the scenes down and correct. And I am going to go get some lunch. Thank you to the supporters on Patreon and supporting me through this rough time. I really do appreciate it. And thank all of y'all for watching. I hope y'all learned something. I hope I wasn't too grumpy old programmer, but I am kind of a grumpy old programmer. Y'all have been amazing. And be safe out there. 7-3.
7-3.
Oh, I don't have an outro or anything. I just end it. Ha! Oh man, I feel bad about not